In section 3.2, we continue working with slope-intercept form. In the following context, you are given the rate of change, however, you do not know what the starting amount is. By your 10th birthday, you have $800 in a savings account. Each year, your parents have increased your amount by $50. We want to create representations of this context in a table, a graph, and an equation. First, we want to identify what our variables represent. So our X value, or our inputs, is going to represent your age in years. The Y variable is going to represent the amount in your savings account represented by dollars. This helps us identify specific points of data that we are given. And what I mean by this is we know that on your 10th birthday, you have $800 in a savings account. So in our table, we can fill out at 10 years old, you had $800. Now, as we said before, we are given our rate of change, and this is due to the fact that we're told the amount increases by $50 per year. So our rate of change is $50 per year. So I want you to take a moment, given these two pieces of information, that at 10 years old you have $800 and your account increased by $50 per year, can you determine what the starting amount was? So pause your video to think about it. So one possible way is to work backwards from this point, 10,800. So if we're earning or increasing by 50 each year, that means at age 9 we had 750, age 8 700, age 7 650, and so on. So then by the time we were born, it went all the way back to a starting amount of $300. So that is our starting, and that means our equation is y equals 50x plus 300. Now, this is not the only way to use the rate of change to find the starting amount, because imagine instead of having the amount at 10 years, we had the amount at 50 years old. That would be a lot of data points to enter just to find the starting amount. So instead, we can work backwards from the equation y equals mx plus b. And we're going to use the fact that this point, 10 is a value of x and 800 is a value of y. So I replace y with 800 and I replace x with 10. But then I use my rate of change of 50. And at this point, my unknown remains the value of b. So I can solve this equation, and I can see that in those 10 years, the amount increased by $500. So then I end up with something like this. And I can see that I've solved algebraically for the value of b. And once again, that would be 300. In example 1, we are writing an equation of the line that passes through the given point and has the given rate of change / slope. So we're applying a context to this information and imagining that you owe your sibling money and give him the same amount each week. So if the slope is 2, then the rate of change would mean $2 per week. And for the point, we might say X represents the number of weeks since you've been giving your sibling money, and Y would represent the amount that you owe your sibling. So the point 5 negative 1 would mean that after 5 weeks, you would still owe your sibling $1. So to write this equation, notice we have a rate of change and we have a point, but we don't have the starting point. But we can work backwards to figure out what that is. So as we said, x is 5, y is -1. So I'm replacing these values in my slope-intercept form. So again, y is -1, x is 5, my slope is 2, and then I'm solving for the value of b. So over those 5 weeks, that means you gave your sibling a total of $10. So you must have owed them $11 in the first place. And I can see that by subtracting 10 from each side. And when I solve for b, I get -11 equals b. Therefore, our final equation, y equals 2x minus 11. In example 2, we are writing an equation that passes through the given points. Once again, we are going to apply a context here to talk about both the rate of change and the starting point. Imagine January 3rd is 32 degrees Fahrenheit and January 4th is 29 degrees Fahrenheit. In this context, the input is the number of days since December 31st and the output is the temperature. Assume the temperature is decreasing at a constant rate. To write this equation, we must first determine the rate of change. So there's a few ways we can do this, but one way is to identify the change in temperature. So from January 3rd to January 4th, the temperature went down by 3 degrees. And I'm just comparing the change in my y values to the change in my x values. But from here, I can figure out the starting point. So I'm going to show what this looks like using a table. Again, on January 3rd, it was 32 degrees. December 31st would be represented by x equals 0. So we know that the temperature decreased 3 times between January 3rd and December 31st, but it decreased by 3 degrees each day. So in reality, I could represent this idea by taking my rate of change and multiplying it by that x value of 3 to be able to determine what my starting point was. So if some number minus 9 degrees equals 32, then we can figure out that number has to be 41. So notice right here, I actually still used an algebraic equation to figure out the value of b, right? Because this represents b. So b minus, and the -3 is really m, the +3 is x, and the 32 is y. So I now have my slope and my y-intercept. Therefore, the equation would be -3x plus 41. I also could have used the other data point I was given. After 4 days, the temperature would have decreased by 12 degrees. And that means my starting temperature minus 12 would equal 29. Well, this value still has to be 41 degrees for this to work. Looking at example 3, we can probably estimate what the y-intercept is right here, but we don't know for sure. So instead, we're going to use the 2 points that were given here and here to calculate it. So using rise over run, I'm rising 3 units and running 5 units, making my slope 3/5. From here, I can use one of the points that I've been given. So I'm going to use this point, and it has the coordinates 1, 0 to help me figure it out. So 1 is x, 0 is y. That tells me that 0 should equal 3/5 times 1 plus my starting point. Well, if I'm solving for b, then 0 equals 3/5 plus my starting point. So subtracting 3/5 tells me that negative 3/5 itself is my starting point. This makes my equation then y equals 3/5 x, again because that's our slope, minus 3/5, since that's my starting point. So while on the graph it almost looks like the starting point is negative 1/2, it's actually more accurately negative 3/5. In our last example, we are told the Buckeye tree you planted 8 years ago is now 18 feet tall. 4 years after you planted it, it had grown to be 12 feet tall. How tall was this tree when you planted it? Well, first we can identify at what rate is the tree growing. So after 8 years, it was 18 feet, and after 4 years, it was 12 feet. So that means it must have grew 6 feet over the course of 4 years. If we want to simplify that to a unit rate, that means the tree grew 1.5 feet each year. So to get the starting amount or the starting height of the tree, we know that it would have grown 4 years from when you planted it to get to 12 feet tall. Well, in 4 years, as we saw before, that means it grew by 6 feet. But since it had to add to the starting height to get to 12 feet, that means it must have started at 6 feet as well. Therefore, our equation would be y equals 1.5x plus 6, or we could have left it as the original fraction that we first found, and that works as well. Next, there are 2 that I would like you to try on your own to find the equation of the lines. Go ahead and hit pause. Before you do, actually, just a reminder with function notation, this first number represents x for the input, and then the second number represents the output. So in both of these cases, you're going to have to find both the rate of change and the y-intercept. So go ahead now and pause the video to try it out. So in A, we can use the change in the y values, so -8 and -2, and then the change in the x values, 4 and -2, to determine that our slope is -6 over 6, or simplifies to -1. Then we can choose either point to help us work backwards and solve for the starting point. So I'm going to use the second point right here. So y is -8, my slope is -1, x is 4, and I'm trying to solve for the value of b. So -8 equals -4 plus b. So that means b must equal -4. And that makes this equation that of the line that goes through these 2 points, y equals -x minus 4. In part B, we can find the rate of change. So X is changing by adding 4, but Y is changing by decreasing by 2. Now notice if we look at the next pair of points, X increased by 6, but then Y decreased by 3. This works because our rate of change of -2/4 is the same as -3/6. And we could even simplify both of those and say our rate of change is -1/2. So from here, I'm going to use this point to determine my starting point. So X is 10. So I take -1/2 times 10, since that's my slope, add it to my starting amount, and this should total up to an output of -2. So when I solve that, -2 equals -5 plus b, add 5 to both sides, -2 plus 5 gives me a b value, or a starting value, of 3. Therefore, y equals -1/2 x plus 3. I could have used any other point. So for example, if I replaced 10 and -2 with 4 and 1 instead, so I'm just using different values of x and y, then I'm going to still get a b value of 3. And I can see this once I simplify. So 1 equals -1/2 times 4 is -2. Add 2 to both sides. And what do you see? B still equals 3. So no matter what point I use, I can determine what the starting point is. And just to summarize, you can find the y-intercept, which as we know is the starting amount, by using the slope/rate of change, along with a given point to work backwards, just like in the example below, where a slope of 2 goes to the point 5, 7. 5 is x, 7 is y. 2 is m, since that's the value of your slope. So our total change is 2 times 5, which is 10. So subtract 10 from both sides tells us that our starting value is -3. So this equation would actually be y equals 2x minus 3. So at this point, go ahead and work on the practice problems. And make sure to write down any questions that you may have.